Okay, so this problem is a special request problem. This is under case 3 because we have a quadratic factor, and also this is also case 2 because we have a repeating linear factor. So we have here the integral of x squared minus 2x minus 1 all over x minus 1 squared times x squared plus 1. So as we can see, the denominator is already factored. So all we need to do is perform the partial fraction decomposition. So rewriting, so we have x squared minus 2x minus 1 all over x minus 1 squared times x squared plus 1. So this will be equal to, so the denominators of the partial fractions will correspond to the factors of the denominator here. So we have for case 1, so we will start with x minus 1, and then another will have a denominator of x minus 1 squared, and then plus another fraction with a denominator of x squared plus 1. So for the numerators, so since we have here a linear factor, so in the numerator we will have a constant unknown a. Also here we have a linear factor, so the numerator will be a constant unknown, so let's say that is b, and then here we have a quadratic factor, so in the numerator it must be linear, so we will write it as cx plus d. Okay, but instead of writing just x, so we will write it in such a way that later on it will be easier to integrate. So we will write x as the derivative of the denominator. So we have the denominator is x squared plus 1, so its derivative is 2x. So therefore we will have c times 2x, okay, plus d. Okay, so next step is to cross multiply the the denominator. Okay, so for each of the terms, so we will have x squared minus 2x minus 1 is equal to, so multiplying this with the first term, so it will cancel out x minus 1, then we will have a times x minus 1 times x squared plus 1, okay, plus b. So if you multiply this, it will cancel x minus 1 squared, so what will remain is x squared plus 1, okay, plus, so we have c times 2x plus d multiplied by, so if you multiply this with this, what will remain is x minus 1 squared. Okay, and then let's expand this, so we will have x squared minus 2x minus 1 is equal to a, so multiplying this, x times x squared, that is x cubed, so negative 1 times x squared, so minus x squared, x times 1 will have plus x, 1 negative 1 times 1, so we will have minus 1, plus we have b times x squared plus 1 plus, so expanding this first, so c times 2x plus d times expansion of x minus 1 squared, we will have x squared minus 2x plus 1. Okay, so distributing this here in c multiplied by 2x, so we will have x squared minus 2x minus 1 is equal to a times x squared minus x cubed minus x squared plus x minus 1 plus b times x squared plus 1 plus So multiplying 2x for each of the term, so we will have c times 2x cubed minus 4x squared, and then plus 2x, and then plus, for the last term, we'll have d times x squared minus 2x plus 1. Okay, so the next is we will now solve for a, b, c, and d. So but first we can solve directly for one unknown by substituting a value for x. Okay, so as you can see here, we have a linear factor of x minus 1. Then if we substitute x is equal to 1, so some of the terms here will become 0. Okay, so those that contain x minus 1. So we can solve directly for b. Okay, so let x is equal to 1. Then we will substitute it here in the first one, because in the first one we haven't expanded it yet. So we can clearly see where x minus 1 is. Okay, and then those terms that contain x minus 1 will become 0. So let x is equal to positive 1. So this will become 1 squared minus 2 times 1 minus 1 is equal to, so a will become 0 plus b times 1 squared plus 1, and then plus c will become both c and d, since both of them are multiplied with x minus 1, then both of them will become 0. So therefore, we can now solve for b. So this will become 1 minus 2 minus 1, so that is negative 2, is equal to 1 plus 1, so we'll have 2b. So dividing both sides by 2, we'll have b is equal to negative 1. Okay, so next is we can equate coefficients of similar terms. Okay, first one for x cubed. So on the left side we have 0. Okay, so we will now look at the last expansion. So x cubed here is 0. Here we have a plus 2c, right? So it's equal to a plus 2c. For x squared, we'll have here 1 on the left side is equal to negative a plus b minus 4c minus, plus d. Okay, so since we know that b is equal to negative 1, therefore we'll have 1 is equal to negative a minus 1 minus 4c plus d. So transposing negative 1 on the other side, it will become positive 1. Then 1 plus 1 will have 2 is equal to negative a minus 4c plus d. Okay, so let this be our equation 1. Then this is our equation 2. Okay, so next is for x. We can write it here. So for x, on the left side we have negative 2 is equal to a plus 2c minus 2d. Okay, so let that be our equation 3. And then for constant, so constant on the left side we have negative 1 is equal to negative a plus b. Don't have a c, and then plus d. Okay, So since we know that b is equal to negative 1, then negative 1, so it will cancel out. So therefore, we will have negative a plus d is equal to 0. Or if we transpose a, we can also see that a is equal to d. Okay, so let this be our equation 4. So here, to make our equations easier, so we can substitute a is equal to d. Okay, to simplify, you can substitute d is equal to a. You can also replace d in here. Okay, so as you can see, if we substitute equation 4 in equation 2, we can now solve for c. Okay, so substitute 4 in equation 2. So we will have 2 is equal to, since a is equal to d, then negative a is equal to negative d minus 4c plus d. So therefore, we can cancel d. Then dividing both sides by negative 4, we will have c is equal to negative 1/2. Okay? So using equation 1, since we now have our c, using equation 1, okay, we can now solve for a, and whatever value of the a is, it's also the value of d. So substitute. So from equation 1, we have 0 is equal to a plus 2c. And our c is equal to negative 1/2. So therefore, we'll have 0 is equal to a minus 1. Or a is equal to 1. So therefore, from equation 4, d is also equal to 1. Okay? So we now have the values for a. A is equal to 1. B is equal to, where's B? B is equal to negative 1. C is equal to negative 1/2. And D is equal to 1. So therefore, our integral will now become, okay, so from here, so the integral of x squared minus 2x minus 1 over x minus 1 squared times x squared plus 1 dx will now become integral of, so a, so what was the value for our a? A is equal to 1. So therefore, we'll have 1 over x minus 1 plus b, the value for our b was negative 1. So negative 1, and then x minus 1 squared plus the value for our c was 1/2, negative 1/2. I'm not sure, so let me check. C is equal to negative 1/2. So following this, so this, so negative 1/2 times 2x, okay, plus d, which is equal to a, which is equal to 1, over x squared plus 1. Okay, and then dx. Okay, so distributing, so this will now become, so distributing the integral sign and then dx, so this will now become, the first term will become integral of dx over x minus 1, and then For the second term, we have negative. So it will become minus integral of dx over x minus 1 squared. Okay, plus. So we can separate these two. Okay, so the first one will have integral of 1/2, negative 1/2 times 2x over x squared plus 1 dx. And the other one will have plus integral of dx over x squared plus 1. Okay, so as you can see, we have here a numerical coefficient, so we can take that outside the integral sign. Also here, this can be solved using the general power formula, where n is equal to -2, so we'll transfer that on the numerator. So rewriting this, so dx over x minus 1 minus integral of x minus 1 raised to -2 dx minus 1/2 integral of 2x dx over x squared plus 1. Okay, plus integral of dx over x squared plus 1. Okay, so we can solve this using natural logarithm. This one, general power formula. This one, natural logarithm. And then this one, inverse trigonometric function, arctangent. So this will now become ln of x minus 1. Okay, minus. So this will now become x minus 1 raised to, so checking, so the u part is the complete differential of x minus 1, right? So no need to add any constants whatsoever. So x minus 1 raised to -2 plus 1 over -2 plus 1 minus 1/2 ln of, so as you can see here, the numerator is the complete differential of the denominator. Okay, so we'll have ln of x squared plus 1. Okay, plus integral of this is, we have our u is x and our a is 1. Okay, the numerator is the complete differential of u, so therefore we just follow the formula, 1 over a arctan of u over a. So 1 over 1 arctan of x over 1. Okay, and then since we already finished integrating, so plus c. So simplifying, so we will have ln of x minus 1, so negative times negative, so plus, and then this will be on the denominator, so plus 1 over x minus 1 minus 1/2 ln of x squared plus 1. Okay, plus arctangent of x plus c. Okay, so that's it. So good luck.